Friends, good morning to everyone. In the last presentation, we have looked into the applications of sonochemistry, utilization of ultrasonication in accompanying the reactions. You have seen that the chemical synthesis can be achieved by using the homogeneous medium or in the heterogeneous medium. The homogeneous and heterogeneous medium, and in homogeneous medium it can be aqueous homogeneous medium or non-aqueous homogeneous medium. And you have seen few of the reactions which were carried out in aqueous and non-aqueous medium under homogeneous react medium liquid conditions. Today's subject of discussion is heterogeneous sonochemistry. As we know, as it is heterogeneous, the different reactants are in different phases. One of the heterogeneous reactions is utilization of phase transfer catalysts. Whenever the phase transfer catalysts are used, it is phase transfer catalysis. These phase transfer catalysts are used when the two reactants are not soluble in a single phase. One may be hydrophobic, which may be soluble in organic phase. Another reactant may be hydrophilic, which may be soluble in aqueous phase. And when we combine this aqueous phase and the organic phase, they separate. The phase transfer catalyst, when we use and we irradiate by ultrasonic waves, there will be the disruption of this phase boundary between the organic and the aqueous phase. By this disruption, it facilitates the movement of the catalyst from aqueous phase to organic phase and hence facilitates the reaction to undergo. This is the salient feature of ultrasonification of phase transfer catalysis reactions. We can see one example. Treat this organic compound with chloroform in the presence of sodium hydroxide by using a phase transfer catalyst like triethyl benzyl ammonium chloride. We got R and S configuration products in the ratio of 4:1. Under normal stirring condition, the reaction for completion it took 9 hours and the yield was just 15%. Under ultrasonication, the reaction time has been reduced from 9 hours to 3 hours and the yield of the product is increased from 15 to 83%. Almost 6 times the reaction rate has been increased and the reaction time is reduced. This is the utility of ultrasonification in phase transfer catalysis reaction. Another set of reaction is reactions with metals. cholesterol derivative, when it is treated with zinc and acetic acid and ultrasonicated, the cholesterol has got converted into cholesterol derivative within 10 minutes, which took several hours in the conventional method of heating. The diester, in the presence of potassium metal and toluene as solvent, when it is irradiated for 5 minutes, it underwent cyclization to give the corresponding cyclopentanone derivative. The alkyl halides, treated with a weak electrophilic carbon dioxide in the presence of zinc as the catalyst and DMF as solvent, when it is irradiated with ultra waves, the reaction gave the product, the carboxylated product, within 10 minutes. The Ullmann reaction, the 2-iodonitrobenzene, 2 moles of it, reacted together in the presence of copper as the catalyst and DMF of the solvent at 60 degrees centigrade to give corresponding biphenyl derivative. In conventional method, the copper was used 10 times excess. When 1 mole of iodonitrobenzene is used, we have to use 10 moles of copper. And the time taken for the reaction to complete was 48 hours. When it was carried out under ultrasonication, the reaction time reduced from 48 hours to 10 hours, and at the same time, the utilization of copper catalyst, which was 1 is to 10 ratio, has been reduced to 1 is to 4 ratio. Reformatsky reaction, the benzaldehyde was treated with bromoethyl acetate under conventional method using zinc. It took 12 hours and heating at 80 degrees centigrade, which gave 61% yield. The same reaction under ultrawave sonication, the reaction completed within an hour and the temperature of reaction was reduced from 80 to 25 to 30 degrees, almost at room temperature reaction occurred at almost 98% yield, equal to almost equal to 100%. 100% conversion has been achieved. These are few of the examples in which reactions with metals using ultrasonications, few of the condensation reactions are being carried out using the metals, synthesis of dihydropyrimidine 2,1H one, benzaldehyde reacted with beta keto ester and urea in the presence of ferric ammonium nitrate, ultrasound, ultrasonication using methanol as solvent, it gave corresponding pyrimidine derivative with 92% yield. Under normal conventional condition, the yield achieved was 60%. Cycloaddition reaction, Diels-Alder reaction, can also be accompanied by ultrasonication. The vinyl cyclohexene, which is a diene, reacts with the dienophile under ultrawave sonication. It gave Diels-Alder adduct. Under conventional method, it took 12 hours of reflexing and the yield achieved was 45%, whereas the same reaction was completed within 2 hours at 45 degrees centigrade with 65% yield, with 20% improvement in the yield in less than 2 hours at not at reflexing temperature. These are all the utility of ultrasonic heating and accompanying the chemical reactions and achieving the desired products. Wherever possible, we can use ultrasonication and the reactions can be carried out under ambient reaction condition with better yields. These are the salient features of ultrawave sonication reactions. These are the applications of ultrawave sonication in chemical synthesis. This is the brief applications which I have given. For further, you can refer the literature. There are n number of reactions which are carried out using ultrasonic waves. All reactions may not be accompanied by ultrasonication, but however, it can be achieved in many of the cases. Wherever it is possible, let us utilize ultrasonication and achieve the targets for synthesizing the drug like molecules to the novel chemical entities. Next, we can deal with other aspects of green chemistry. Till then, have a nice day. Thank you.